Okay. Welcome. Come back to JoCademy. JoCademy. We are back, and today's lesson will be about You may be asking yourself, what is fact? I'll show you a fact. So, let's say we have the equation 1/2 equals 2/4. Well, what if I decided to see what makes... Let me show you something. I multiply 2 here and 2 here, and that equals 1, and then now it's 2/4 times 2, and that is also equals 2 times 2, 4 over 4 equals 1. Now, why is that important factoring? Well, basically, this part of factoring is what, this is what factoring is. You have a multiplier, and you have something inside, you take it out or multiply it in, and you get an answer. Well, I have a bad explanation for that. Let's just start with example. Hold on, let me find it. Okay. First question. 2x squared, cubed, plus 12x squared plus 16x. Now, I forgot to mention earlier what factoring really is. Oops. But basically it's finding a common factor amongst an expression or equation, and you basically divide that and put it as a multiple. What I mean is, look at these. What do they have in common? Well, for one, obvious one, they all have this x squared, x cubed. They all have x. But notice how they don't have 2x squared. They have only 1x, this is 1x, this is 2x's, this is 3x's. If this were to be a 2x squared, you would probably put x squared parentheses 2x plus 12 plus 16. But you don't do that, because there's no x squared. And since there's a common factor of x but x to the 1, you factor out only x. X parentheses 2x squared plus 12x plus 16. Oh my god. Okay, so back to what I was saying. X out of here. So now we just divided x from every term here, divide by x, and then put this x onto a multiplier, so we can multiply it back and get the same expression again. So we're not done factoring here yet, but look at this. Is there a common factor in here? One slightly less obvious one than the x is the fact that it's all 2's. All of them are divisible by 2. So, we're going to factor out 2. 2 x parentheses x squared plus 6x plus 8. Now, this is a less obvious thing, and you need to know in a mathematical concept, principle, whatever, in order to keep further factoring, because from here you're like, wow, you probably can't factor any number. A and 6, they're 2. You can factor out 2 between them. You can factor out x and x here, but you can't do x or 2 between these two, so you can't factor them. Well, you actually can factor it. And here's the trick. You want to multiply this term with this term, right? 8x squared, and it's to make an x, and now we have 6x. So why do I add these numbers? Well, I'll tell you why. This is how we're going to factor, what we're going to use to factor. So this is a multiplying, and this is addition. These two numbers need to add up to 6 while multiplying to 8. And the answer to that would be 4x and 2x. Because 4x times 2x is 8x squared, and 4x plus 2x is 6x. And you can kind of see how this is related to factoring, and how I explained it here, where 4 and 2 are shared amongst, and x are shared amongst these, all of them. So if you were to split these, so how you're going to split them is, well, let's ignore this real quick. So now you put x squared plus 4x plus 2x plus 8. Now, what you're gonna do is factor out from here. So, let's factor out this and this now. Notice how I didn't do that like this, because that would be like something else. It would be like x plus 6, and you don't really have anything to do after this. But from here, you split off into 4 terms. Now you can do a lot more factoring. So, factor out x from these two terms. So now it's x times x plus 4 plus, now 2 and 8, factor out 2, that's x, 2 times x plus 4. Now from here, we are not done. Notice how this term and this term are the same. We can actually divide it by x plus 4 and put it on the parentheses side over here. So now, that's multiplying x plus 4 with what's left. What's left is x plus 2. So multiply x plus 2. That is now factored. And remember, I put 2x here. So the answer would be 2x. Wow. How does your answer, Colin? I forgot to tell you that I made this video for Colin. Alright. Now, let's get to another example. Okay. Alright, next example is 3x to the 6. 3x to the 6 minus 27x to the 4. Now, you may not see it at first, but x and x, they share 4. Why 4? Because when you divide fractions, you minus fractions. Alright, so what you can do is get rid of x to the 4, and now it's 3x squared minus 27. Now, you wouldn't know this, but 27, you know what 27 is? Alright, hold on, let me show you what this is. This is 3 times x squared minus 3 times 9 squared. Wait, no, just 9, my bad. Or actually it's 3 cubed, but let's just say it's 3 squared. 4. Yeah. So now you see something. You can divide 3 from each side, or each part, and then have a square on each thing left. So let's do that. So that's 3x to the 4 times x to the squared, oops, okay, minus 3 squared, and this is our principle. This is some formula in math, in algebra, called difference of squares, a squared minus b squared. You know what that's equal? It's equal to a minus b times a plus b. Well, I'm not explaining how this was even found, but just remember this will always work, because normally when you multiply parentheses of this, usually you get a squared plus 2ab plus b squared. Or you could get a squared plus b squared. Sorry about that. Or, alright, so this is equal to a plus b squared, and then this is equal to a minus b squared. Usually it'd be like minus 2ab plus b squared, right? Well, just imagine if you kinda did a thing with the thing, you know? Imagine this. Go away. Actually, this one, go away, and this one go away. And you now have a minus b squared, and that'd be equal to this, you know, and you add it, and it don't matter what I'm saying for now, it's just random, but this is what you should know. A squared minus b squared is equal to this, and we see that here. So a is x, a and b, and so a minus b, x minus 3 times x plus 3, and it's times 3x times 4. Oops. And that should be the answer to that. Alright, let's go to another problem. It's apparently the hardest problem by column. I don't know what you're on, Colin, but a little special. So here's the problem. Hold on. Let's see. I'm always talking about my eraser. X minus 1, x plus 4, equal x times x plus 5. Oops. Notice how these are already in factored form, and essentially this is a solved equation. This is a solved problem. We're trying to solve for x. And you might think, there's so many x's, what are you gonna do? Well, let's go backwards. It's in factor form. So, let's work backwards. Either x minus 1 was the common factor, or x plus 4 was a common factor within a process. I'm gonna just do x minus 1. So, x minus 1 was a common factor, so it would have been like x plus 4 minus x plus 4. And that's similar, and this is similar in style of this, you know? But this doesn't got a factor, so that's crazy. Well, anyways, what you do next is just distribute x squared plus 4x minus sign is minus x minus 4, okay? Minus 4x, that's just x squared minus 4. Now hold on, this is a difference of squares. Hold on. Now, it's actually not. My bad. It's just 3x minus 4. Okay. And that's equal to, let's distribute x squared 5x. So, to find out x, the easiest way is to just set this equation to 0. So by doing that, you just minus x squared and minus 5x onto this side. So x squared minus x squared, x squared minus x squared is just 0. Minus 5x, 3x, that's negative 2x minus 4. And then that's equal to 0. So what you do is factor out negative 2, x plus 4 equals 0. Negative 2 divided by itself, negative 2, this goes away into 1. This turns into 0. So now it's x plus 4 equals 0, and x equals negative 4. Hold on, let me see if that's... Oops. Oh wait, oops, my bad. This is 2. Okay, hold on. This right here is a 2. Equals 0, same process though. Divide, blah 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 blah, 0. X plus 2 equals 0. X equals negative 2. Yeah, there you go. Don't ever hit me up at like 9 p.m. to ask me how to factor when you're in geometry, little bro. And then when I give you the answer, you tell me that I'm doing magical shit and I could probably use photo math. I did not. You're a dumbass, alright? My bad for my language. Bye. As for rather.